Welcome to part 4 of quadrilateral theorems with Mathomat. Theorem 6. If you can prove that the diagonals bisect each other, that is, if they halve each other, you have a parallelogram. Let's have a look at our diagram. Here we've got two diagonals and they intersect each other at point E. And if I move point F from D to E, the length is 5.5, which is half of 11. And from E to B, another 5.5 will get me to 11. So we know that the diagonal DB is being halved by the shorter diagonal. And if we go to the short diagonal, point F from angle C to the intersection E, which is the midpoint, I'll have exactly 3.3 for a length. And if I move it back down, 3.3 units will get me back to the center, which is the midpoint. So these two diagonals definitely bisect each other, and this proves this quadrilateral to be a parallelogram. Let's head on over to the template. This parallelogram was enlarged using the template, and you will see I've cut along the longest diagonal. I've also drawn the short diagonal in. To ensure that the long diagonal halves it, we can simply measure the two segments and make sure that they are indeed the same length. And once we've measured them, we have the proof that the long diagonal bisects the short one. To prove that the short one bisects the long one, I'm going to use a slightly different method. I'm going to flip over this triangle and I'm going to fold along the long diagonal. And what we want to achieve here is to get those two angles directly onto each other so that when I fold down on this triangle, I know the fold will be exactly in the middle of the diagonal, which is also the base of this triangle. Alright, so I folded it over and my short diagonal is exactly on the midpoint of where I folded my triangle over. Let me open it up and you can see we have that exactly in the middle. So that's a neat way to prove that the two diagonals bisect each other, and if you do the same to the other triangle, you will achieve exactly the same result. I will leave that up to you to go and check. And if I place these two onto each other, you'll see that it is exactly halfway down the side. And of course these two triangles are congruent. And that was a practical way to check for the diagonals bisecting each other. Let's have a quick overview of the properties of a parallelogram. All of the properties of my parallelogram stays intact when I move this about. And if the one angle changes, the other one changes accordingly, and the same goes for the sides. But what will happen if I break the properties? If I make one little small change, look at the impact it has on the rest of my quadrilateral, which is not a parallelogram anymore. So one little small change in any of the properties will result in you not having your original shape anymore. I can't call this a parallelogram anymore because I've changed the properties of this quadrilateral. Let's have a look at how we can decompose a parallelogram. There's a triangle and a rectangle and another triangle, 2 scalene triangles, and another pair of scalene triangles. So how will we define a quadrilateral to be a parallelogram? Well, it must have both pairs of opposite sides parallel. Also, both pairs of opposite sides must be congruent. One pair of sides must be both congruent and parallel. Both pairs of opposite angles must be congruent. One pair of opposite angles will be congruent and one pair of opposite sides will be parallel. The diagonals will bisect each other. If your quadrilateral has those properties, then it is a parallelogram. I will be demonstrating this drawing with GeoGebra's software. I'm going to demonstrate how to draw a parallelogram. So first I've got 2 points, A and B. I'll be joining these 2 points with a segment. There we have a segment. And of course we want to make sure that we get a parallel line to that. And I'm selecting a point C, which I want to be parallel to AB. And I want to show you that as I move my segment AB, my parallel line will move accordingly. So if I now connect C and B, I've got my second side, and again we need a side that will be parallel to that as well, because AB is still parallel to the line that point C is on. So I'm selecting a parallel line to BC, and I'm just going to manipulate this so you can see that the new line I've added there is parallel to BC. Of course, I've got an intersection there, and I'm going to just get the point of intersection, which will form the vertex of this parallelogram. Here we've got our sides marked as well. My theorems are holding up here. My opposite angles stay congruent. My opposite sides are parallel to each other. They're also congruent to each other. Thank you for watching this session on parallelograms.